literature on this. So, but we can see that this type of exercise improves the quality of the patients, the quality of life of patients. And we shouldn't forget, and we don't insist on this, the sensory and proprioceptive re-education. With so proprioceptive means so trampoline use, and to have the eyes closed, eyes shut, eyes open, and to put the patient on a platform which destabilize him, and sensory re-education with different tissues, and to have him walk on different tissues. So this has an important effect, and we're trying to have this. And all the physical work in this patient leads to muscle pain, and the physical activity, massages, and stretching improves the quality of life for this patient. And once again, all the rover equipment and And for the shoes, people are not very satisfied with the shoes, and in the summer it's difficult to put the shoes on sand, etc. But more and more patients go to internet and they equip with it, and they are quite happy with it. And what enables to have a correct activity and to improve this. So stretchings are necessary. We have to show them as 2-3 times a week is not sufficient. They have to do it at home with the re-educator. And the frequency is very personalized. It depends on the age of the job, the occupation, and it depends on the age of the so it is individual. Thank you. So that the patient could adhere to this and observe this treatment, so that there can be a beneficial advantage. So we can also use occupational therapy, and the material supports can be used in the severe forms, and also the splint to avoid the member to shrink. So surgery in the adults, we don't use it a lot, and it's not. We need multiple surgeries, and we have to be cautious because the food structure is very delicate, and if we touch the balance of this food articulation, it's very difficult, and the patient keeps some pains and they are not satisfied, and you really have to have an experienced surgeon to do that, and who knows the different techniques and processes. But in the painful forms, when there is an osteotomy because the toes are gray, or there are foot deformation leading to pain, there is no hesitation, and we have to have a trained surgeon. And the patient that I've seen were satisfied. So we can learn from this. And once again, in the hand of experts, and while saying to the patient that we can do it to improve the quality of life of the patients. to improve the quality of life, we have to treat the pain. For a long time, we have said, and on, on Facebook, that some doctors say there is no pain in Charcot Marie, but when you see 180 patients saying that it hurts, we have to accept that there is some pain in this, and we have to find some ways to relieve this pain. So anti-inflammatory, we cannot use them for a long time. The means physiotherapy means to use it as much as possible. But neuropathic pain, you know, the treatment is anti-epileptics or antidepressants. But as much as we can, we should use the non-medicine means, and especially stretching. Fatigue is a complaint, a very important complaint. So how to treat fatigue, we have to accept this, and we have to believe what the patient says, and we shouldn't neglect the sleep apnea. So it leads to fatigue, and so people wake up at night, and after that they are tired. So we have to detect these pathologies on which we can have an influence, and we can give some vitamin C, and was a certain efficiency against fatigue with these vitamins. These are small things, but the association of small things leads to a lot of things. We can we shouldn't be depressive, and we shouldn't depress the patient and say there's nothing to do. There are always things to suggest. Therapeutic education. So far that I know, there is no therapeutic education dedicated to this. We will try to launch this in Marseille, and the association is very active for this. They made some videos, etc. So now the future treatments, what gives us some hope. The only therapeutic trial which has been made, and the only one who brought something new, the only one is the association of sorbitol, baclofen, and naltrexone. This showed in a... Before saying that, the concept is very interesting, because this medicine, we know this, it's on the market, so so each of the molecules acts on different ways to reduce the production of PMP 22, and in this AAC enzyme, in order to reduce the production of PMP 22, which is the overexpression is toxic. So each of them acts on different ways in order to reduce the production, but the side effects are different. So the association of this treatment enabled to have a potentiality to use these medicines at very low doses, and we already know the side effects, and so it enables to dispatch the side effects for good tolerance. So this is the context of paleotherapy. This is a very interesting concept, which was published in 2011, and so we began a first phase in 2010 in France, and this is where who was saying that? It was Pascal Sintas, And the therapeutic effects, these are the French teams which are the most active on these trials. So in 2010, we made the first trial, so 80 patients were included. 3 doses were tested, and so this shown a certain degradation after 1 year. And the intermediary dose wasn't showing a lot, and the last one showed a certain efficiency. So we went to a third phase, which confirmed these data. So 523 patients were included. So these are the parameters, the primary criteria, ONLS and ONLS, and we can see the dose effect, placebo, 2 intermediaries, and the higher a dose is still a low dose actually, but this dose has a certain effect. This effect is slow. I prefer to say the patient that this effect is slow. Is that possible to come back to the other slide? It was positive. I cannot come back. I will continue, no problem. So this confirmed the phase 2 data. So the problem was that during phase 3, there was a crystallization of product, and we had to stop the trial during 2 months. And but the authorities wanted a confirmatory phase 3, and now we have the extension data. The study finished in 2014, 2015, and now we have it's 5 years from now, and according to the laboratory, there is still this effect that we can find, and some animal studies, which were led by an independent group, Sereda group, which confirmed. So this study is in progress. Once again, around 350 patients were included, and the first year has gone. The patients go to the second year, and we'll have the results in 2 years, I hope. So concerning the other treatments, I'll go faster. So you've seen that lavoafinal is still PMP22, lavoafinase. This was PXT303, and there is the gene therapy. The problem of the gene therapy, the idea is so the gene becomes silencer. So the problem is that this is an excess of protein. There is a mirroring pathology at HMPP, and so if you reduce the production, the patient will be HMPP. So it's not the ideal. So this limit, we cannot control this limit. And then by acting on the intermediary RNA, there were some publications, and there was no follow-up for now. And a publication was made about gene therapy, but injection in the nerve, and there the effects wouldn't be too important, so it's acceptable. So that's the so injection intraneural. So it's difficult, and so this technique, the interesting vector, needs some improvement. So he's creating his startup. So all of this is with the French team. And another study, this is a company from Nantes, and they have a very solid publication in 2015, Cephine 1. It was about cellular stress, so by reducing the cellular stress, the accumulation of PMP reduces, and this recent a recent study is waiting to be implemented in France. And for now, they use it for ALS, so I don't know if they can do it with the Charcot disease too. So something that was very interesting in publication, it was in 2018. It was by acting on the neurotrophin 3. It was a gene therapy, but we improve the transactional regenerescence, and the trials that were made on the man, on 7 patients, the result was very interesting. But since 4 years, we haven't heard anything. So these are the treatment in the CMT1. So the other treatments, the 4 CMT neuropathies are 1B. So in CMT1B, there is a Cephine 1, and the others are at the level of the gene therapy. We are still in the animal model, and I don't want to talk about that when this is not, this hasn't passed to the man, when we are, and people work on inhibitors at every level of actions, and for now, nothing extraordinary. So three possibilities by acting on RN1 or gene therapy. So something very interesting, and I will end with this. This was this publication, about a new mutation, and it wasn't easy. And this gene SORD was discovered in 2020, and it's not so rare in the type 2 forms. This is a frequency which is quite high, about 10% of these forms. So since then, we've made some studies. So this is the French study, which has been submitted for publication. So this CMT2 have some clinical characteristics. So the subject is between 20 and 30, so we go to the spinal atrophy, so the motor forms, or ALS. So there is a continuum. So this gene is very interesting. We do the diagnosis, and there is a relative correlation of a severity, moderate severity, which doesn't encourage the patient to go and participate in the trials. But this is this. Oh, there was something missing. In fact, the gene, the mutation is sorbitol dehydrogenase, and so sorbitol is not used, and so the serum rate in sorbitol increased by 100%. So the first indication, there is a biological marker. So the diagnosis is very easy because sorbitol can be dosed, and so it's quite easy. So there is a biological marker, and we can use it in therapeutic trials to see the efficiency. And the second interesting thing, as I've shown, the sugar-free sorbitol. A sorbitol is like a sugar, so there are two treatments existing at the moment. So the lab is working on this to reduce the side effects. So this anti-diabetes treatment exists. So there is one trial in the US. So we do everything what we can so that the trial can be done also in France. So the sorb rate in the animal, so that the mystery of this computer. So when we treat in the cell in vitro, here this is normal and here it's pathologic. So when we treat with this molecule, the rate comes back to normal rate, and I don't know in which cell it was. It was in the human cell, and unfortunately, with age, the activity is reduced, and this is in the fly, and in the aging fly, the activity is very low, and the subject is here. The affected fly and the treated fly. So its activity has increased, and so there is a rationale to this treatment. The therapeutic trials are here, so this form has to be shouldn't be ignored, and I hope that France will be able to participate in the available trials. Thank you. Are there any questions? Question? Sharam, if you had a CMT1, would you eat curcuma or turmeric? Yes, turmeric is efficient in the animal, but for human, yes. But a mix of vitamin C, vitamin E, turmeric, I wouldn't hesitate to do this. And this is nutrition. So the Indian dishes are very, very good. Meals are very good, and in association with physical exercise. And if we can act on the small things, we can have a few things to change a lot. So what's the expression of CMT in India? Yeah. Yes, you had prepared this question in advance. So that's the same. Yes, they're doing well. That's a good question. But anyway, for vitamin C, I don't know if he had modified his article, but the effect was wonderful. And so the man is different. And in ALS, I don't believe in therapeutic effects. But when the things have not reached a human phase, I remain cautious. Aren't they a combination with of sorbitol with vitamin C? No, now it's forbidden. There was the history of the issue of the sorbitol, which has increased. Well, it's paradoxical. Some say it's good, some say it's not bad. But the sorbitol rate in SORD is very high. For instance, for the diabetic people, the rate of SORB is 2 to 3 times the normal. If we have a diet with a lot of sulfur, you won't reach this rate. I like to ask you, you said that part of this patient suffer from sleep apnea. What's the percentage of this person? In the Charcot-Marie, it's 5%, but we have to do the diagnosis. There were some initial publications saying that it was really important, and it was detected when only when the patient complains, or when his wife complains, when there is a morphology, but it's not so frequent. And is this syndromes of apnea worsen the neuropathies? Not directly, but there is a hypoglycemia, and the patients are tired, and they don't want to do physiotherapy, so it's a vicious circle, and it's worsened the myopathy. Are there biomarkers reflecting the rate of PMP22 following anti-PMP22 strategies? So PMP22 was not validated as a biomarker, but it was researched in all the trials. The English team has proposed a lot of biomarkers. So every year they suggest the biomarkers, but we don't have a formal biomarker in these trials. There is also the neurofilament. So we believe in muscular MRI. There is still this study that published quantified IRM, which is very sensitive. It's also our experience. And if ever the therapeutic trial beginning, we will propose a biomarker. So the MRI, the quantified MRI, as a marker. And if after 6 to 9 months we can see on MRI a modification of the trend, so a change of the curve, of the bending curve, or if there is no response, we will stop the treatment. So maybe the muscular MRI, muscle MRI, knowing that it's very heavy treatment, and so we need some means to do.
We now will continue with Professor Helg Amthor, pediatric neurologist with a passion for research. He's going to present therapeutic trials for Duchenne muscular dystrophy.
Dear Remy, thank you very much for inviting me. It's a great honor to be here and sum up my bio. I live across therapeuties for the Duchenne disease. It's a disease which is fairly quite progressive, as after 15 years, children do not walk because there's a degenerescence of the muscle. Muscular biopsy, you see that there's a necrosis, some generation, but there is a change in the tissue, fibrosis, and the muscular fiber is just disappearing. And on therapeutic hypothesis, there is no therapy that could build back muscles. What the muscles lost are lost. So you need to step in as early as possible to protect the muscles. for for the purpose of protecting the muscle for possible loss. There's a lack of dystrophia, which is a structural type mouse, which is lacking on the left on two tubes here. The imaging department has provided this image, and with a DMD patient, there is no protein. Such protein is disappeared, so absence of dystrophin protein. And therefore, you can reflect and think about how to inject this structural protein. You can't just inject it. If you think about this myopathy and therapeutic strategies, you need to provide it in a different way, this protein, for instance, by appropriate genetic treatment. There is a first work we need to refer to, which is a fundamental one, phase 1 study, that showing that gene therapy is possible, and that led by Dr. Fardo. They injected DNA, full DNA, the whole CDN of dystrophin, and they found fibers that they managed to that restored the dystrophin. So it was in a way successful, but there is an issue of a quantity transduction, viral transduction, which we did not have in the past. We just injected DNA, pure DNA. So we need to find another way of doing this. So it's not sufficient enough to have to treat the whole body. It's difficult to find a gene therapy approach, as the gene is gigantic. It's the largest in the body, over 2 million. And even it's very large, so difficult to input in the cell, and it's a syncytium, and see how each cell is expressing the dystrophin gene. See the small dots. This is dystrophy of the muscle. So muscular fiber. Dystrophin is marked by UGFP. The muscle is in green, and on the muscle fiber there are places such as at the junction. It's you can see it better, more. So this is a transmitter, and is a mosaic. It's a female carrier mice. Each shell, each little cell will express dystrophin. So if we go towards gene therapy, we need to find a way to provide the gene to each cell. It can produce only for a certain surface, not for the whole tissue. So the extension within space, that is very limited to produce dystrophin. If we have a gene therapy, if we adopt this gene therapy, it's possible, as we see with the mice, we manage to do that, and it's not very powerful. So we have small bits on the fiber that was that restored dystrophin, but not a full extended restoration. and therefore dystrophin is not going to be efficient enough. So researchers thought about what to do next. So there were some carriers of the genetic message. So the AAV, adeno-associated virus, can be easily manipulated. Small viruses. And what do we have here? Well, researchers changed the inside and of this part, this genetic information. There is no more replication gene, and we can input the expression of a gene that we choose, for instance, dystrophia. There we could actually have benefits to this. If we change the genetic information of a virus to a transgene that we're going to change, the virus loses its pathogenic capacity, so it cannot then transmit a viral disease. So when if some insects, for instance, if they haven't got their shell, then they are going to be not as protected. Immunity response is possible. Immunogenicity. So, the biological point of view, biologically, an AAV cannot carry a gene as large as dystrophin. It can only carry around 4,000 nucleotides. Shorter, therefore. So we need to think about another strategy. The second point is that AAV goes into the cell, goes into the nuts, the hub, and cannot be taken inside the genomes. It's not like antiviruses. It is could be an positive point, but could also be negative. The virus, the treatment gene, is lost. If there is a regeneration, they won't have. It won't be, in terms of the efficiency, it's limited. So if we really want to have an impact, a therapeutic impact, we need to input a lot of viruses, concentration of 10 times 4 per kilograms. So if you actually represent it, it's like, if you have to draw it on paper, it's like going to the moon and back. So we need to look at also tissue tropism. You cannot use just any AAV. You need to use those who have or are specific to, have specific tropism. And the same as with all viruses, you need to think about the immunity response. There are quite a few patients who already have an infection infected by the wild AAV, and they won't react to a specific AAV we're going to input. Another medical thought. It's excellent to have a therapeutic strategy when we inject once virus and we are cured for the rest of our lives. But on the other hand, you can't dose again. The dosage you can't change, because in the meantime you will have an immunity response. And then you cannot go back. Once you've injected the medicine, you can't go back. Same as, for instance, if you have a side effect, you can't stop the treatment. The treatment is there to stay. Then patients who are going to get into this treatment, they cannot be eligible for other treatment. So if you go in this treatment, then you can if you go on another treatment, you can wait another 6 months, or with this type of treatment, you can't. So what do we do to overcome these drawbacks? They built dystrophins, micro dystrophins, shorter ones therefore. So if you think of a little stick here, which is too long, where you just shorten it. So they looked at what part of the gene are not parts of the gene are not necessary to maintain dystrophin. So there are some repetitions, R1, R2. So they designed some vectors which were built, and today we have 4 types species provided by four companies: Pfizer, Clinical Trials, Government, Pfizer, Sarepta, Solid Biosciences, and Genethon. That started and embarked on this clinical trials. So I won't take you through the technical details of it. So Solid Biosciences Ignite has already tested on 100 patients. First publications already. On the first patients who were injected, that goes back a few years already. In this publication, you can see that, maybe I can show you, out of 7 cases, before a year between, a year gap, there's a diminishing the lower destruction of. So there is an impact, a positive impact, quite a considerable impact by using this therapeutic strategy. So on this score, the patients have stabilized, and we showed that even a few years later, after injecting this gene therapy, patients are still stable. So it's a success on Duchenne myopathy. So this publication points out that microdystrophin is visible here in red, is expressed in the muscle, in the muscular region. You see that there is a presence of this. The protein is well represented. So 4 hypotheses for success of AAV microdystrophin gene therapy. So just one application, one injection. The injection of the protein, fairly wide expression of the gene, and only after a few years down the line, apparently it's a long-term therapeutic effect. And fourth point, most Duchenne patients are eligible. So it's independent of the mutation. But unfortunately, there are some side effects. Can sometimes be severe, such as the ones you see: abnormal distension, pain at biopsy site, thrombocytopenia, muscle weakness, myocarditis, and one patient died. It doesn't happen really often, but it does happen. So there are some immunity responses against capsid, but also against microdystrophin. If the patient has a mutation, a deletion that concerns that targets microdystrophia, which is coded which is present, which is there with some patients. So it generates or it creates a micro episode. So it can be like the effect is like, such as if you were rejecting an organ that you were given. So you need to add immunosuppressive therapy, and delay in trials on non-ambulant patients for safety reasons. So just months ago, just a little over a month ago, they wanted accelerated approval. So I'm really expecting results soon. And there's still some open questions. First question, does microdystrophin, which is designed in is really small and targeting really functional regions, parts. This microdystrophin is as good as just a regular dystrophin, so we can't answer that question yet. Luis Garcia, a researcher, says, well, microdystrophin has a micro function. Others say that it can restore the function, the muscular function completely. And this was conducted with mice before birth and after adult age. There is a dilution with just growth, during growth, dilution of the transgene during growth, and regeneration at 2-3 years old, and the child then older, its muscle grows, and this muscle, the growing muscle, has not been treated by the microdystrophin, and the medical treatment is going to be diluted. And as I showed you, the size, the restoration with dystrophin is limited in space. Well, therefore, there's going to be some fibers, mosaic, disseminated fibers, which are going to lose out their power or their impact. So RNA interference or modulation, splice modulating therapy. So the point here is to use a sequence to target the gene, dystrophin gene, in order to overcome the devastation or the destruction of a mutation. This was by a Becker patient. That was actually applied to a Becker patient with a residual dystrophia. This Monaco regulation here, deletion is 150, leads to myopathy, Duchenne myopathy, but there's some greater mutation, 51, which provide a phenotype not as heavy, lighter, and even some patients have got no symptom. The loss of the reading card of the gene, in other cases the reading card is maintained. So here is a publication by which we actually looked at Becker muscular dystrophy patients with deletions, and most have got no symptoms. So some have got greater deletion but with no symptoms. So how could we change and move a Duchenne patient, move this patient towards Duchenne, moving it to to another. So, so this is color, various colors you see. They represent these colors. If the reading card is maintained with the sequence of the nucleotides with the axon, or columns that are separated on two axons. You have the various colors. You must ensure that each axon finds an axon with same color code. If you have a deletion, let's say 4850, that's quite a frequent one, typical one. You got exon 47, which is not reading the next, or in the reading sequence as the next one. So it's changing in color, and we are losing the reading card, and the protein is going to be degraded with a Decker patient. So yeah, change the Duchenne patient into a Decker patient. So 4851, so reading card is maintained, and the protein therefore is shorter but functional. So we are using nucleotides that are targeting some areas in order to cover up an exon, which is going to be treated as just a bridge and exclude the reading of this exon. So as you can imagine, some exon represents 15% of mutations in DMD. If you can suppress 51, that would allow to restore dystrophin. So you can think, okay, here we have a deletion of 45. If you take out 45, we've got the transcript, which is this is more for a Baker patient, and that could restore dystrophin. Same with destruction of exon 51 to 52. That we can work out some strategies, and it's different from micro by injecting microdystrophin, by restoring, just doing it this way. Well, if we do the other therapy, we leave out the whole DNA. So artificial DNA, it's exon skipping in DMD. Some were tried in the past and were too toxic, and therefore they were left aside. Some are still being tested, and one of which has been granted accelerated approval. I'm just going to tell you about it now. So we developed a tricyclo DNA. I'll tell you about it later, but just so that you know what it is. We have nucleotypes. Nucleotypes you need to produce in a chemical environment these nucleotides, and they are sequenced to make up a small nucleotides chain, oligomer. And you can just make what you want, and you need to target some areas, part of the virus, to cover up or to hide some exons of some in the liver, for instance. Today we can only treat in a certain way with these molecules. And this is one of the first publication with research on. That was the first research, and that goes back 10 years ago, 10 years old. And this shows that after 3 years treatment, dystrophin has been restored. That shows it has been restored, but in small quantity. It's one patient, one patient that has been targeted. So in time, over time, we are going to we extended this clinical survey and compared this to some sample cohorts, and we compared this to past experiences, loss of walking within 2 to 3 years, breathing, respiratory function, the loss of the breathing functions, and from first diagnosis to 3-4 years later. So that's how we analyzed it. It's not a curative therapy. It's not a cure, but it slows down. So they received the accelerated approval, and roughly 1,000 patients are being treated in the US. In Europe, we still have not received any approval because we are still lacking or missing some hard data, phase 3 testing. So new clinical trials are still ongoing with in France, in Mission trial by Trousseau eye motion. And the second one is Essence, with exons 45 and 53, skipping. That's been going on for 96 weeks. And in the meantime, we are working on other therapeutic ways. So add small bits to improve the passage between blood and the cells. One of the new treatments that is being used is PPMO, which are peptide phosphorodiamidate morpholino oligo. And there is an ongoing trial, unfortunately, not in France. And there is another approach by which PPMO are added to a fragment, immunoglobulin fragment, and that started 2 weeks ago with the first patients. And finally, we are advertising our lab. We've developed a new chemistry, Sky 51, based on DNA tricyclo-DNA chemistry. Chemists have added 2-anophenol to a carbon atom, and 20 years we've been working on this, 20 years. In the meantime, we detoxified the molecule, and short story, we added also a residue, a fat residue, and that changed the pharmacokinetic for the better uptake of the tissue. We submitted this to the Commission. We should have some feedback. I haven't received any feedback yet or any answer yet. So shortly, we're going to be recruiting in Grache, including 12 patients, so from pediatrics unit and adults as well. And that's going to be conducted over a 1-year period of time. And first, we're going to check that the treatment is well supported by the patients. Pharmacodynamics, so we're still looking patients, maybe some patients here. And with this, I'd like to sum up briefly. So we have, at the same time, new medical treatments used by the approved by the FDA and used in the US. So Exondys 51, Vyondys 53 for exon 53, Viltepso for also exon 53, Amondys for exon 45. Some still in a clinical trial phase. For the gene therapies, we got microdystrophin Sarepta. It's ongoing as well, to be assessed by authorities, and others were still in a clinical trial phase. So I did not have time to mention the last one. Last one is a trial conducted by Flanagan on therapy, gene therapy, that provides that will give us the opportunity to publish. Thank you very much. Do you have any questions?
Vous avez des questions? Merci, professeur. Est-ce qu'il y a des questions parmi le public?
Can you tell us about duplication on the exon 2 duplication therapy? There is a Geneton at the time, Luis Garcia and the whole team, we showed that it's feasible to use an AAV to carry a U7 that can link up a small sequence. And this build was brought back to the States, and it was made suitable of upscaled or scaled for duplication of exon 2. Duplication of exon 2 is the most frequent one amongst any duplication, and the nicest this therapeutic approach. If you take out exon 2, that is an additional, you reach to dystrophy, a totally normal dystrophia, and it's just beautiful. And we could not expect an immunity response because there's always a basic expression by fibers. So it should be really successful. What do you think of non-dystrophian approaches, non-dystrophic approaches? What do I think? Well, I was all for it. And I was instigating this, but we could not show its efficiency. Interpretation of the data is tricky, as a cohort was better placed than that patients from other backgrounds. So difficult to conclude, to come to any conclusion. So there is an extension phase. We're still working on it. Not necessary to have in place other therapeutic strategies, which most likely additional strategies, especially that there's going to be epigenetic alterations, which means that transcription as such of the gene is diminished. And we are now considering inhibitors to strengthen suppression or exon suppression. Other strategies which attack the tissue's well-being, which we will talk about later. Toxicity of what are the impact, adverse or side effect, adverse impact off target you could have, and how do we study, how could we study this, or what are the animals we should be using for experiments, procedures? Yes, we noticed that toxicity of antisense to nucleotides is based on, well, it relies on whether the links between the phosphors, is there a substitution of oxygen with sulfurs? Is it toxic because it changes the DNA, artificial DNA, and changes it into something which sticks to all proteins, and that leads to activation of supplements. One other thing we notice is that the species which are the best to be used, mice does something totally different than primates. Interaction in the brain, human brain, is different if we look at it from, depending on whether we use mice or monkeys. And if today we conduct works on regulated toxicology researches. We cannot do it any other way. We must do it with primates, non-human primates. Otherwise, we haven't got any feedback or real insight in terms of impact. And quite a few teams studies point out that it depends on the chemistry and it depends on the sequence as well. You can't say if we can, if our molecule works, if we take the same chemistry and configure it in different way. We can't ensure that the pharmaco impact is going to be the same, and the toxic impact also by, for instance, toxicity by activation of supplements is going to be the same. Thank you very much.
We will now welcome Professor Yann Péréon from Nantes, who will talk about the new treatments in myasthenia. So, thank you very much for inviting me. I'm very happy to be here today with you. And this was said in Creole. So, point on an assessment on myasthenia. Thank you. So, myasthenia is a structure of muscular junction that we know, and now neuromuscular junction, and we know the different proteins which are involved, and we've discovered more and more genes involved in the congenital myasthenias, and is enabled to have a better understanding of autoimmune myasthenias. Concerning the autoimmune myasthenias, we have the antibodies, the anti-RAC antibodies, 80% of the myasthenia, and they act on two folds with direct actions on the receptors and on a direct way. And the anti-mask represents a lower portion, and this reduced the same way the gathering, the grouping, and the presence of the antibody. And also the anti-LRP4 and maybe others that we cannot identify so far, but it will come. So the treatment of myasthenia is symptomatic for symptoms anti-acetylcholinesterasic medicines, and also so for the crisis, immunoglobulins 4 and plasmatic exchange, and in the long term, for the long-term treatment, thymectomia, corticoids, and immunosuppressants. And up to 30% of the patients have an insufficient response for corticoid, or sometimes a very high side effect. So this is a slide. I won't comment all the elements, but just to underline that the immunity treatment, the classical immunity treatment is zatioprine, which has been used for several decades, and there's no big side effects. But this is a this is a medicine which is largely used. And at the bottom of this table, I want to underline the fact that a treatment which is more and more important is rituximab. It's been used for a while by by lung specialists, and the rheumatologists now begin to use it too. So you have the treatment by thymectomia, an introduction of a long-term treatment like cortisone, corticoids, and azathioprine according to the age, and some supplementary treatments are more and more used in myasthenia. The treatment of myasthenia is like a glass of water. It can be half empty or half full, and this is a pathology that we know more and more, and we have a lot of treatments in this pathology. And these remain, so this is the neuromuscular pathology for which we have the most treatment. If I make a parallel with the Charad pathology disease, and he began his presentation by the functional reeducation, and I convinced by the importance of this treatment reeducation. But when we compare, we are on a situation where we don't have a lot on the CMT. So we have a lot of treatment. So this is the half full the glass, and the half empty glass. Up to 80% of the patient don't have a stable remission, and 20 to 30% of the patient aren't responding or have a low response, and 10% of the patients are reluctant or intolerant to the current treatments. So corticoids are not expensive, but they have a lot of side effects. And reducimab, or it's sometimes difficult to have the injections. And there are the unmet medical needs. So what are the new strategies in autoimmune myasthenia? So the one who are arriving are there are two inhibitors of the FcRn receptors and inhibitors of the complement. So we will come back in detail on the treatment of these two groups. We will be at disposal in the next weeks, months, or years. And if we see other things that can be done, so anti-C5 or FcRn inhibitors. You can see them on the left, but there are other treatments like medicines like the drug called rituximab, inebilizumab or AMAB, CAR-T cell therapies, and we also have other drugs like other medicines like obi, obinutuzumab. So you can see satralizumab, and the targets are different according to these medicines, and so there are a lot of medicines, and there are other tracks, other approaches which will be further will be more sophisticated, and these techniques I don't master them, so I won't tell about them, but proteasome inhibitors also. We are more these are more sophisticated medicines for later. So we will come back to the data concerning the two current classes of medicines, inhibitors of the FcRn. So the FcRn receptor is a protein which will link, which was bind with the IgG immunoglobulins, and before entering in the endosomes, and they enable the recycling of the immunoglobulins in the circulation. So if we inhibit this receptor, we enable the degradation in the Ig cell, and so they won't be recycled, and they will be less numerous in the circulation. And so it has been proved that it reduced the IgG antirax, and it increases the clearance, and this limits the toxicity of the anti-RAC and anti-MuSK. But it's not only anti-RAX or anti-MuSK. So there are 4 medicines for which the trials are advanced or have been completed, or the marketing is already done. So efgartigimab, rosanolixizumab, and batoclimab with the company. So I will examine 2 medicines among them. So the first one, if is administered by perfusion, efgartigimod. So 167 patients included in this study. The results were published in 2021. So 4 perfusions, 1 per week, and then an evaluation and other cycles of perfusion. So the evaluation for all the studies I presented are around the same type of score. That's the equivalent of the GARS score, or activities of daily life for the last 8 days, the last 8 days, and score of quality of life. But whatever the scales use, they are quite similar. And so here, the efgartigimod, the mode of presentation will be the same for the 4 slides to come. So beginning of the treatment, the treated group, the placebo group, the scores. I don't know if they are readable, but these are the scores that I've quoted. QMG, so quantitative QMG, the quality of life here, and to the right of the screen, the part minimal improvement in favor of the efgartigimod or the placebo. And what we can see on the screen, corresponding to the results published, it shows an efficiency in the improvement of the scores after 3 to 4 weeks. It begins at 1 or 2 weeks, and then the maximum is reached after 1 month, and then it disappears. And an important element, I could have done the comment on the following study, but in the myasthenia there is a placebo effect, which is very important and more important than in other pathologies, and so it is a bias on the results of this study. So the placebo effect is more marked, and what we could imagine that when when we see this patient, this myasthenic patient in consultation, well, people say they're tired, and I just say, yes, we just say move. But for real myasthenic, we want to. Sometimes we feel like shaking these people, and maybe these patients are more sensitive to the placebo effect in these studies. And anyway, the FCAR-TG mod shows an improvement, leads to an improvement. The second example is the rosaluxizumab, and there was a study on a small number of patients. 43 were randomized, evaluations on the QMG, so score of daily activities or composite. So we have subcutaneous once a week, but this is an element that we have to take into account. But here the study is negative. The study was made in the same, under the same conditions. You can see the result, and you see the type of presentation is the same, but the product is the left on this part of the screen. And we can see the same curve in U, and schematically we can identify the fact that the placebo is not so far from the medicine, but personally I think that it doesn't change to the likely interest of this product in the pathology. And with some more patients, we would have some more characterized things. But to illustrate what I was saying, with this type of treatment, when we see what's happening about the rate of immunoglobulin, we can see that the project will be is responsible of a decline of anti-RAC. But normally we don't follow the anti-RAC antibodies when we follow up when we follow a myasthenia. But the patients sometimes say, well, the rate is higher than before. But this is not a good marker. It can be a good marker for the action mode of this, but it's the quality of life which is important. An inhibitor of the FcRn, inhibitor of the FcRn, and then we have the inhibitors of the complement. And in this nice drawing, we will talk at this the C5 and the complex, which plays a role in the anti-RAC pathology. And there is the ravulizumab and silicoplan, which are more advanced. And so for as far as inhibitors of the complement are concerned, so I present the same type of schemes of drawings with a higher number of patients and a heavier therapeutic treatment. So perfusion every week for 1 month. And then we increase the doses, and so this treatment is heavier for the patient. We have the evaluation on the MG-LDL, and an element that I didn't mention for none of the 3 studies is the type of patient recruited. And so these patients have some intermediate myasthenia, and there is no pure myasthenias. And this is the same as the preceding. It means that as far as the statistics are concerned, the efficiency is not demonstrated, but we are here on the anti-C5 medicine. We have a longer action time. We have a low decline, and then it goes higher. But we have the same type of things. We have the treated group and the placebo group in red. And well, we can see that it works, but we can see the importance of the placebo effects here in the patient who didn't receive the eculizumab. So there is a bias in these studies, but it means that it doesn't question the potential interest of this type of medicine in the myasthenia in terms for the myasthenia in terms of efficiency. And this was the Regain study, and the extension phase. They had detailed the patient who had myasthenia that was treated or not by rituximab, and the fact that it was treated by rituximab didn't prevent the potential efficiency of eculizumab in the patients receiving this medicine. And the last illustration of my of this is with zilucoplan with fewer patients, 44 patients, and with a reduction of 6 points on the QMG. So these are similar situation, and we have the same type of information, and everything is almost the same. We could superpose the results that were presented with an efficiency which will be confirmed in the future. This little table just to explain some of the criteria of these trials. So 3 for the inhibitors of FcRn and 3 for the C5 inhibitors. So number of patients, it corresponds to the starting group, which was more important. We have to keep in mind the selective side for the anti-C5, but for the FcRn, it can concern all the patients with autoimmune myasthenias and not only the anti-RAB. And the evaluations were quite the same in terms of criteria of response criteria, with the activity scores of a daily life, a QMG, the duration, the shorter duration, but we should improve the duration of the study and increase the number of patients. I think that the negative studies wouldn't have been with this. And administration, the administration is more comfortable for these medicine because it's not an injection. And in the inclusion criteria, there were the ocular myasthenia, which weren't concerned, and the patient the patient had to have some antibodies. And we talked about congenital myasthenias, and this. So for the myasthenia, it can be also sporadic, but even if the patient is 40, it can be congenital. Sometimes I will show you a 70-year-old person. So how will we mix the products? So former medicines and new, and what about the age of the disease? I present the autoimmune myasthenia like a comet with a big initial flash, and at the end of the queue of the comet, and so it will install, and during years it will install somewhere. So in this comet, according to the time where we intervene, so how efficient will be the treatment. So the evaluation criteria were the QMG activities of the daily life, but some things were criticized on the fact that patients respond honestly, but sometimes they don't respond to what we would expect when we ask them, is there a problem for the shampoo or for your hair? And they say no, because for shampoo someone washes my hair, and to brush my hair I use a support. and also the poverty. Um, Also, the side effects are not weren't taken into account. And a word concerning the biomarkers. We have some diagnostic biomarkers, the anti-RAC markers, the EMG. I'm a fan, but we don't have any predictive markers of myasthenia. We would like something like neurofilaments, for instance, but we know that if it's the anti-RAC, we can use some anti-C5, and that can be an indication of thymectomy. And so this is a kind of biomarker. And there is one element which wasn't used, not what was always used, concerning the weight and the IMC, which can be identified here as an element of risk factor, potential risk factor of autoimmune disease in general. And second point is the cost. A Cortensil tablet each morning is not expensive, even. But eculizumab, if 650,000 euros, and Rajimab 400,000 euros. So someone has studied the cost efficiency relation. So how much does a pharmacy costs? So they have estimated the cost of Avgar at $20,000. So it's far more than the actual cost. And when we prescribe, we want to prescribe the most efficient medicine independently from the price. We want the patient to have the best treatment, but things are expensive sometimes. So what can we say? That's the antagonist of the FcRn receptor are quite quick, and it can have a quick you can have a quick relapse after that, but the tolerance is good. I said that there were some syphilis, but well, what in terms of positioning, in patients which have a bad response and with EG or EP, but while we wait to have an efficiency of the neurodepressant, as Murad said, can be a good tool for an initial phase of treatment to avoid corticoids. So inhibitors are only for the anti-RAGs, and also concerning the quickness of action, this alternative to corticoid could be a good alternative. And in an article which is always 2 years old, so it's almost an eternity in terms of developments about myasthenia. I will end with this slide. We are in front of a white page on which we have to write things in terms of new treatment. And I will quote the conclusion of an article which will be published and which is accessible online, and which say that for now we don't know exactly the place that this there is uncertainty around the place that these drugs should occupy. So personally, I don't have experience about these medicines. There are a few patients. I think you have some, Wally. Things are beginning to use them, and we will have some in Nantes, and the real life will play a role. And to end completely, for those interested in the EMG of the child, come to the International Congress of Pediatric Electromyography in La Baule in France. We have some nice beaches, not as beautiful as here, but go. I have a question about the FcRn antagonists. You've shown a curve where there was a decrease linked to the stop of sorry, there is a curve showing a bend and then a return of the anti-RAG. So is that linked to the interaction of the antibodies injection? So what happens if we persist, we continue to inject? The infectious risk will be more marked. It depends on the way it is used and the way it was presented, a cycle with a perfusion, and then it decreases and it goes up. So there are a lot of examples of treatments it was done. But the idea is how we will use them, because the groups of patients for which were selected in the studies are similar on the 4 or 5 studies. And it's not only these patients who are concerned, but it's far more, the scope is larger. So the white page is really the illustration of this issue. I will ask Guillaume what he thinks about the Solaris, etc. And how we tried to couple plasma FRS and anti-FRS. Do you have the answer? Just on one patient. There is an administrative delay to obtain the medicines, and so the Rosimap we have already began to deplete with the plasmatic and then take the relay with the Rosimap, but there is no interest doing a plasmatic exchange with the patient having Rosimap under Rosimap. It wouldn't be interesting to do a FcRn inhibitor. I don't see them as an alternative to the long-term treatment, either corticotherapy or radiotimab. A patient was included in the 003, and so she received the Rosimap in series, so 6 perfusions, and we wait till it worsened. And she's been there since March 2020, and now we continue on the extension study. And in March 2020, after 2 weeks of stop, we come back to the Rosimap, and so this will conceal the disease, but it won't stop the production of antibodies on the long term. Yes. This is an alternative of this very severe patient for which we use the IgEV. For the autoimmune disease, there will be other treatments, and it will be difficult to include other patients in the trials. We have too many medicaments on myasthenia, but not enough on other neuromuscular diseases. And I agree with the white page. We're still learning for now. Just a small question. I know that the Rosimap is made in Bordeaux, is used in Bordeaux, Solaris elsewhere. Among the treatments that you've mentioned, are these drugs available in ATU? Those are available either in ATU or without. Is it available? Cargenio? At Cargenio, yes. My second question, do you have the experience of seronegative myasthenic patient with this treatment? When you need an authorization to prescribe, it's part of the exclusion criteria. Excuse me. We need the microphone. If it doesn't speak with the microphone, we cannot hear the Just, I was saying that when you have a pharmacoresistant negative patient, before escalating the therapies, so why not still asking the question if it's not something else? I will show examples later when it's drug resistant. Thank you very much. Oui.
Thank you, Professor. We continue with advances in gene and cell therapies from sickle cell disease to muscle fibrosis. Professor Anne Galley, Interim Director, Genethon Research Director, AFM Telethon.
Thank you. I'd like to thank the organizers. Thank you for inviting me. So yes, indeed, I will tell you about this rather unexpected field, but I will go back into the muscles. Please, my presentation. First slide. Just a reminder, the background of the gene therapy that has been applied with more and more trials, increasing number of medicine, and a very dynamic sector. Just a reminder that therefore the impact is going to come in quickly, rapidly in medical practices with various protocols, with a whiteboard, with new opportunities for gene therapies. We hope this for these rare diseases. Modalities are various, in vivo, ex vivo as well, with various adenovirus, adeno-associated virus, retrovirus, lentivirus, liposome and plasmid, not used anymore, but yes, we have quite a few tools. We have many strategies, various ones with gene therapies, genome edition as well. Now faced with all those techniques, we need to be very expert in our field. So my specialty is to manipulate the ex vivo gene and cell therapy using hematopoietic stem cells to correct rare genetic blood and immune disorders and have impact on the progeny of cells. So based on this, we're going to go back to the muscles. Just a reminder that in this field, Genethon has set up a program to treat rare diseases based on gene therapies, with some programs that went under clinical trials. Various treatments, so X-linked chronic granulomatous disease, device vectors to address certain deficiencies in Artemis deficiencies, design vectors to treat sickle cells disease, and other approaches that are under work, and technology platforms, ex vivo platforms. One question that we can ask ourselves, and we can answer as well, is HSC gene therapy safe and efficient with stem cells? Is it safe and efficient? Yes, I'm sure. Remember that there were some adverse result consequences. And with all treatments, across all treatments, patient treated with these gene therapies have been reviewed. 55 ongoing studies, very different ones. 57 patients treated, 406 participants. All were observed with LT or Almost all vector-induced oncogenic events occurred with the use of the LTR and GRV in primary immune deficiencies, with the highest induction with this kind of vector of the leukemia and adverse consequence between 4 and 5 years old. Most patients have been treated with this kind of vectors who had been then developed leukemias. And the only trial that was so one patient 5 years later had leukemia after this treatment. So still is but this is due to insertion of some oncogenes that are. We developed this technology. We quickly. What I mean by we is scientific community. Gamma retroviruses we used and against the antiviruses of the HIV. We designed some cassette concepts, as you can see, initial vectors using LTR promote transgene, and using inner carrier, and that's what we're using now. We know also that we must go from productions or make craft, make do just productions to vectors which are purified by chromatography and GMPs in pharmaceutic establishments, institutions. So we designed this to address some specific issues with Scott-Aldrich syndrome, CGD, and Fanconi anemia. We didn't notice any adverse impact, and no issues with gamma and retroviruses. And as far as I'm concerned, these clinical trials and multinational trials, which showed that in those publications, through those publications in various articles, that the efficiency and feasibility made these approaches with antiviral vectors. We've got CGDs, NetCGD, Jonathan, where actually had a positive impact in the long term. So we worked with Frederick Bushman, the way we could integrate this in clonal integration. One patient here who has been analyzed and checked at several points in time, T cells, PNP, T cells, and others. So full heterogeneity of the insertion of this vector, which did not raise any issues of genotoxicity. So if we take stock of what happened, Jonathan conducted trials in France, UK, US. Our Italian colleagues developed the same vectors, the same type of trials in Italy with 17 patients. And all this work and researches were published and did not point out to any genotoxicity, and which was not the case in the past. So today we have strong results. So efficiency has been evidenced. There's no bleeding, and therefore now we have follow-up beyond 15 years. So these clinical trials are in long-term clinical trials. So results back up what has been published in this based in not based but applied to various pathologies, hemoglobinopathies, disorders, congenital problems, issues. 79 patients were taken in. 3 cases were identified with a clonal problem, clonal dominance in B-thol, so this B-thol patient. 2 syndromes with myodysplastic syndromes, therefore MDS and LAD, benign. And we have 1 case of sickle cell disease case and you're 5 years down after this treatment, but we are uncertain as to what happened in terms of this gene had been affected. So this case is not clear. So overall, the profile has been secured. Gene therapy has moved on, and the cost of HSC-based LV gene therapy is high. So we have medicine that have been recorded, LMD or MLD, that has been recorded and identified as to treat in the gene therapy but medicine. But it's the cost, as I just mentioned, is really high. Sickle cell disease medicine is still very high. 2.8 million pounds, 2.8 pounds per patient, 2,800 pounds. Well, very high anyway in terms of cost, and it's really expensive. So we have severe diseases for which we could consider pay this kind of medical cost, but what do we do for not rare diseases? And I have in mind sickle cell disease, which is a genetic disease with connected to a special mutation. Hemoglobin chain has been a mutation of the hemoglobin chain with a falsification of the erythrocyte, and of course crisis and all the impacts and follow-up. Yeah. So this is consolidated by mutation of HBS, and this makes it possible to have solid interactions between the various chains of hemoglobin chains. We know that anti-falciforms hemoglobin, beta hemoglobin, that have a mutation forms, which make it possible to alleviate this interaction beta-alpha, alpha-beta, beta-beta, and a fetus as well, which makes it possible to reduce this falsification. One vector which we have, globe, okay, lentiviral vector globe AS3, which was developed in LA. 3 punctual mutation making it possible to have these anti-falciforming vectors, which was developed and proved to be able to express again levels almost at the therapy level in experiments, in vitro experiments on patient cells. You can see the expression of, well, in terms of percentages, based on a number of copies per cell, and you need to go up to 2 copies of vector integrated per cell to express HPAS3 to have an actual impact. So we need to reach this high rate of transduction of stem cells to have this kind of impact. It's fairly difficult. You need to optimize this process so that in the high proportion or most proportion of cells you have this kind of expression. What we aimed at doing is in our laboratories, if we could use some stem cells from the umbilical cord, which are young and permissive to transduction, and express a fairly high rate of fetal hemoglobin. If it was possible to use this umbilical cord as a way to do this, so we set up a protocol, DEPREC cord or something, which intends to collect, which in a hospital, umbilical cords. So we with carrying this mutation. So we're working with imaging with various hospitals and centers and imaging centers, and we are working on transduction of cells, showing that we can have transduction, and we can design methods and have this rate of 2 copies of integrated vectors per cell, making it possible to have a therapeutic impact. And via HPLC, we see also the expression of hemoglobin, and with both patients that were homozygote, we could have two turns of transduction. Bottom right, you have indeed twice as much transgenic hemoglobin than more than the usual, than the regular. We could use stem cells that were not too affected by the disease. What are the possible technological evolutions to reduce cost and improve gene therapy and reduce cost? And in this approach, we always have one main issue is the cost of it, and antiviral cost to produce this. And so new approaches, new ways to for the genome. CRISPR systems, some projects, ongoing projects on collaboration with some other institutes, Geniton, trying to use CRISPR Cas9, right? So fetal hemoglobin has an impact, anti-falciformer, as we know for some time now that there is a gene that exists, a mutation with some patient that can reduce seniority of syndromes connected to sickle cell, so that interference, having an interference with the fetus. Fetal hemoglobin is expressed with the interaction, through the interaction of transcription factors, which are displaced and inhibited after birth with this. So we are using CRISPRs to re-express in a permanent way fetal hemoglobin and the gamma chain, which has an impact anti-falsifier role. And there is editing. There's an article that was published, and we're going to be using this, and we're going to work with Mario and these people. This technological platform is going to be has already been tested in clinical environment. Can be used not just to alter and change stem cells, but also lymphocytes as well. And corticells, I don't know if you know corticells, taking means that you're going to be taking some cells and modify them in vivo with antiviral something, and have an impact, T-cell activation and transduction. So this has was a revolution. This was a revolution in cell immunotherapy for oncology as well. So the CAR can lead anti-cells. Quite a lot of work done as well to develop receptors and links to attack the environment of the tumor, antigenous tumor. So there can be a derivative approach to have anti-fibrotic impact. One of the targets that we could talk about, one of the something we could target is protein targa. Fibroblast activating protein A alpha, right, and which circulate not much, but the advantage of this protein is expressed as a low level, but is extremely high level when you have an induction or you have cancer. It's 80% of this protein is zero. In 80% of the cases we find this protein in cancer cases. Indeed, targeting of this FAP has been used by colleagues in the past to inhibit fibroblast present in some tumors, and that was reviewed recently by some colleagues that the use that CAR T cells against this cell can actually attack the tumors. These colleagues thought maybe shouldn't we use this strategy to lower the precursors, fibrosis precursors in cardiofibrosis. So they demonstrated recently that you could induce in the mice fibrosis, cardiofibrosis, and then quickly add some corticells to reduce cardiofibrosis, as you can tell in here. No, so we thought about it, and we thought, how could we use this strategy, corticell strategy? So I won't tell you what is Duchenne again, because you all know, and it's obvious that when we know that Duchenne is a loss of dystrophin, basically, that's a disease that leads to a loss of, not a lack, but a loss of dystrophin, a loss of fibers, satellite, also destruction and of satellite cells, and fibrosis. We think that the efficiency of the therapies, and especially epigenetic strategies, are going to be harder and harder to get to if your tissue is going to be fattened and become fatter and fatter, and will make it difficult to receive this treatment. So obviously we'll have to use a combination of therapies to have a real impact, and especially with the Duchenne disease. So we have experimental models. We have mice and MDX mice, and as you see on the left at the top, the MDX on C70 black 6. And underneath, you have, just below it, you have a different background, and how the fibrosis got worsened. So we looked in laboratory environment, fat marine impact. We injected that in the muscles, the mice muscles, and you can tell that the fat collagen 3 in LDL, in orange or white type, is overexpressed, especially on the gastroc, and compared to the control mice on the left. So you have a good rationale. So we decided on an antivirus. So this antivirus was provided by colleagues working in cartilage for leukemia. So we replaced the antibody, the leukemia antibody, and we replaced this antibody and validated this model injected this in mice cells, so that we activated in vivo to have the fat car in the body. So when MDRDX, we give them 1 or 2 injections. We have some mice with cells CD8 positive with a phenotype memory vector, which have a very active way of reacting, and see how the effect and the impact of the treatment. In orange, we have MFAP that has been created by 1 doses, 2 doses in dark green, CART2T. So this fat core or CART-T have got an impact, FAP car. Diminishing of collagen, lowering level of collagen. So we can generate fat car that we need to suggest specific and functional MFAP CART T cells can be generated with third generation CAR lentiviral constructs Fab CAR T cells demonstrated dose-dependent functional effect to reduce fibrosis in vivo, and promising adjunct treatment of DMD to reduce the spontaneously occurring skeletal muscle fibrosis. So gene and cell therapy has broad application potential. Gene and cell therapy using lentiviral vectors in HSC have a safe track record and are efficient in the long term. Immunotherapy using CGT may represent novel options to treat fibrosis and may be useful adjunct to GT, and gene and cell therapy technologies are evolving towards cost reduction. Genome editing with safety evaluation in long term require new sources of HSC, in vivo delivery long term as well. So possibly we are going to move from strategies by improving in vectors we are going to be using in applying our treatments. I'd like to thank all the colleagues, all the partners who have worked, AFM Telethon, and we have quite a few colleagues working with us alongside on the myopathy, and they funded most of this work. And we could not have managed all we did without them in the clinical centers. Thank you for listening as well.
Thank you, Professor. Any questions?
Quelles sont les maladies? Merci beaucoup pour votre topo, c'est super clair.
Thank you for your presentation. Very, very clear, quite intricate. But from your point of view, what are the neurologic disease that are most favorable to gene editing? Yeah, for gene editing. Gene editing. The gene transfers could be treated by gene editing in ex vivo, in vivo. Gene editing in vivo is the issue we have come across with all other approaches, is how to apply it. We have biodistribution as targeted as the genomic fact as possible. So no toxicity, so the case 9, we need to handle this toxicity level. With Genethon, we are working on the off-target toxicity, and there's a whole body. We are going to be we're going to do this sampling, and from a genetic point of view and sequencing, it's not easy. Slicing is not easy. We have immune responses as well, and against case 9 and all various vectors. So we need to overcome all this. So for now, well, in ex vivo, we first need to show evidence that it actually works. From a neurologic in vivo point of view, not right away. But if I take the example in triplets disease, something you cannot treat with gene transfers, with case 9, she can cut down these triplets, and we need to deliver the components and things which are ongoing, and I'm sure that we'll be, soon delivering something.
Est-ce qu'il y a une autre question sur l'effet antifa de protéines? On the anti-protein effect, we have seen some bad side effects. A patient has died, and so we had to reduce the dose of Fogenome. So what do you think about off-target? I don't know if I understood the question, but I think the challenge, the stake in gene therapy, especially in Duchenne, is that we need to use some high doses of vectors and of ego. This is a massive target that we have to correct, as you explained. So every strategy enabling to reduce the doses and to have less less side effects and less genotoxicity is good, would be good. And we hope to demonstrate that with the anti-fibrosis approaches, we will be able to reduce the dose, especially of the vector, in order to have the same effect. Alitroginose is the alitroginose. It's a alifibrotic medicine, so it's to discuss. And there were some high undesirable side effects, and so we had to reduce the doses, but it's difficult with anti-fibrotic agents because we can have effects in other tissues. Yes, you're right. And the principle is that you remove some cell because if we will remove the precursors, and we would have to act relatively early, and we would have to pass the threshold of toxicity if we remove some fibrotics in the tissues that could develop. We don't know how it will evolve, and what I want to say is that colleagues working in the framework of the cardiac fibrosis is that they have shown that prove that we can use the delivery of lipid nanoparticles with RNA, and it is reprogrammed temporarily to express and to have a cytolytic effect, and it can have an effect on the induced fibrosis, cardiac fibrosis. Okay, thank you very much. Thank you to all the speakers of this session. So the next question is, so we are an hour late, so ladies and gentlemen, so good evening. A few practical logistics information. For those who have registered for the gala evening tonight, it will be at the restaurant at the bottom, at the level of the beach, tonight at 8 p.m. And for the people who have booked the transfer between hotel and the hotel and the airport, you have seen the paper boards outside with the program, and we will add the departure time for each of you, for your driver who will bring you to the airport. So do not hesitate to consult this information board. And you have my number. I'm Thierry Blanc. My cell phone number is on the board if you have a question or observation. So please go to the coffee break. We are late. And he didn't say what time we're back.
Bon, allez, dernière session.
So last session of the day, of this first day, this very busy day about neuromuscular diseases. So please, a little attention. So please come back to your seats. Where is Professor Lemasson? So I have the privilege to present Dr. Mireille Cosset, genetician at the General Hospital of Montpellier, University Hospital, and she's a specialist of titin. Titin is not as big as a gene as dystrophin, but this is quite big. So thank you, Cyril. Thank you for inviting me to present today in this wonderful framework, in this wonderful environment. And I won't thank my colleagues who went to bathe instead of listening to my presentation about titin. So I won't talk to you about the secrets of the jungle, which were the films which were proposed, suggested in the plane. But I'm more specialist of titin, and I'll try to expose quite simple the secrets of titin and how the multiomics can enable to advance and to find the secrets of titinopathies. So titin is a giant protein, is the biggest protein of the organism, of the body. And so titin is represented here, and it's half sarcomere, so you can see it, and between this band, and it's linked to actin and myosin. It's important. By enabling the contractivity of the muscular fibers. So this is a big gene of 353 exons, and 363 exons. This is a very complex gene, and with some repeated regions, repeated blocks. I won't enter into details at this time. So the titinopathy, the first phenotype was described by Professor O in 2002, and at the time we sequenced only a part of this gene, and Pierre Méan has seen some myopathies from this, with a late onset, frequent in Finland, with dominant autosomic, and with an identical mutation in the Finnish patients, with the insertion of deletion of 11 PB, and other mutations of the exons 363 and 364 were identified. So since then, it was called titinopathy, and since then we can sequence the whole gene, all the exons of the titin gene, and we were able to identify the fact that titin had frequent variants, and titinopathies are very frequent pathologies, and the variants are from several types, from all types. It's represented here: truncating mutation, splice mutation, in-frame insertion deletions, and so all types of mutation distributed all along the gene. And it is difficult because this mutation can lead to a recessive effect, or a dominant effect, only one variant, or nothing. We all have some titin variants in our body, and it was demonstrated that in the general population, the truncating variant, reducing the size of the titin, are present in about 1% of the controlled healthy population. So we have to be cautious in the variance of the titin. So for the clinical part, in red, circled in red, there are several types of clinical syndromes, and with the evidencing of mutations, we evidence more and more clinical symptoms, and there are several different phenotypes. With the age beginning, the onset, it can begin prenatal, and up to the aged adults. The older has more than 80 is more than 80 years old. So we can have some retractions or no retraction. This is not a unique phenotypic picture. So the histology can be very varied. We can have a cardiac impairment or not. We can have a titinopathy, which are only cardiac with another genetics. The mode of transmission can be dominant with only one variant, and a transmission from parent to child, or recessive when we have two variants inherited from each of both parents. So we have currently more than 10 syndromes that Raúl Fontas Morales had illustrated in 2020, with either the myopathy with an adult onset, which can be recessive or dominant, or the early onset myopathy with only recessive symptoms that were described. So what are the basis of this phenotypic complexity? As I said, the subject today is to talk about the multiomics. What is multiomics? If in the cascade, we have an intermediary step, the DNA, which will give the protein, and protein will be matured and interact with other proteins, and we will be submitted to modifications due to external phenomena. And so the multiomics is the analysis of all these steps with I will give you a few examples of this multiomic of the multiomic studies, and I will illustrate with some examples of a research project from our laboratory called the Diagnostic Project, consisting in recruiting patients for which we have these elements, and we correlated with the genotype identified in our laboratory or in another laboratory. And then we will analyze the transcriptions and then an analysis of the protein. And the analysis were targeted, and then more and more we have high throughput analysis. And we have currently 22 investigator centers, and it will last until the end of next year. So what's the use of this? This is the example of the HMERV, where it was demonstrated that the mutation were all in the exon 344 with a relatively simple correlation. Recently, Marco Savares published a study demonstrating, which is very interesting for those who could be interested, about the correlation between phenotype and genotype, so genotype-phenotype correlations in recessive titinopathies. And he saw a correlation between the location of the mutation in the M band with titin with the clinical severity, and it illustrated the fact that if this M band is very reduced, very truncating, we have congenital forms. If it's not very reduced, we will have some forms in the childhood or later. So we can have some myopathies with some recessive type. So you can see the complexity. At the lab, I will give you an example of a new phenotype with a new mutation that we've published recently. It is two families with distinct distal myopathy of the lower limbs, and we presented our study in Marseille, and another family was shown. Françoise Chapon said she identified another family in Normandy with the same phenotype and the same mutation. And what was this mutation? It's a CNV, copy number variant, a big deletion in the gene involving several exons, 11 to 18. So I won't enter into details for this family, but the CNV, it was one of the first time that we could identify a dominant CNV in titinopathies, and this is a loss of function anomaly, so it should have been recessive. And we made some studies with a transcript, and this deletion was in phase, but with the introduction of an intronic part in the breaking points. So this is a truncated protein. We don't understand why this is dominant. We don't understand why some patients are less symptomatic. This is quite frequent, this variability. So there are things to identify in this type of family. And then we have a study of the transcripts. The transcripts are very complex. We have a meta-transcript of 364 exons, which expresses only in the fetal period, and we have 6 isoforms in postnatal. Some are expressed more in the heart, some in the skeletic muscle, so we have specific transcript. And what is complex, is that in these specific transcripts of the heart and our muscle, we have some exons which are excluded. So I will show why it was important to show this, and it's Marco Savares, which is an expert in titinopathies, who demonstrated in this drawing that, for example, we have 100% of transcript, and in the other example, there is not at all, not any exon expressed. What we have shown evidence in the laboratory is that, in our laboratory, is that these RNA studies are necessary for every patient. At the beginning, we wanted to do that only for patients who had some mutations, but we have shown that we have the example of a patient, a female patient with congenital myopathy of moderate evolution, and we have a mutation of the splicing 312, and we saw 3 bands with this transcript. We had 3 bands, and we had an intermediary band which uses the splicing site, but it modified the reading. And so finally, this patient have the wild type protein. It has the one with the exclusion of 312, and it also has truncated titin participating in the patient's phenotype, and we were able to evidence some more complex transcripts that we didn't expect. And so now we will study the transcript for all the patients with RNA5. And so why did I speak about this exclusion of some exons in the physiological transcript? Because it enabled the OATS team in Australia to do some phenotype OATS team to do correlations, phenotype-genotype correlation. Some had some retraction or arthrogryposis, and so they demonstrated that 1/3 of a patient have an exon which is low or not expressed, and 1/3, it's a lot. And surprisingly, these patients seem to improve with age in a marked way than in other congenital myopathies. And so maybe they improve because mutations, if it's not in a postnatal, in postnatal, the mutation won't express because the exon doesn't express itself. So maybe there is a recovery, but we have to confirm this on other cohort. And so that's why in our study we have we selected this study to have at least in this study to have at least one of the two variants in an exon which is not well expressed in postnatal phase. So we will now go to the protein. So I won't detail our cohort, but if you have some question, I can come back to this. So this is a giant protein, the biggest of the human body, and this protein, this hemisarcomer, has several proteins interacted with it. I will focus on two examples of evidencing of anomalies of proteins interacting with titin, so calpain 3 and myosin, and how the identification of a secondary anomaly of these proteins can explain the phenotype. The first example is 3 families with an Emery-Dreyfus-like phenotype with an onset in childhood, retractions, rigid spine, and a form, recessive autosomic form. And they have evidenced. Oh, you can see the control. So here, this is the control, and P1 is the patient. And you can see the 3 isoforms of calpain, a lack of calpain in the patients compared to the control. And surprisingly, no mutations of calpain have been shown. And this team has evidenced some mutations in the titin gene, so recessive mutation with in the interaction with calpain 3. So their assumption is that the defect of interaction with calpain 3 could lead to a degradation of calpain 3 and participate in the phenotypes of this patient. And in the laboratory, we have identified in 2 brothers presenting a congenital myopathy with a pelvian weakness, and they presented a typical sign of fat infiltration of the tendons, and we could see at the muscle biopsy, we could see a variation of the size of fibers and central nucleus and cores, and but there was an absence of muscular fibers of type 2A, and the analysis of titin showed three variants of the titin, of which two in an interaction field with myosin. At the western blot, in the titin, we didn't see the band with the truncated protein due to the duplication of maternal origin. That's one of the limits of the western blot. But what you can see here, we demonstrated there was an absence in the patient, in red, in an absence of marking of the MYHC2, although the MYHC1 was present. And so we searched if there was mutation of genes with MYHC2 that was known, and so the assumption was it would be a default of interaction with titin, between titin and the MCH2, which would lead to this degradation. So what are the perspectives of these multi-omic approaches? So we do DNA-seq sequencing, and we do some analysis RNA-seq, and for the Western blot, with the titin is identified, but it's difficult to show a moderated decline of the size, and we are not quantitative because this protein is too big to have something quantitative measures. So our most recent project, which is supported by the AFM and the FieldNemus, is to set up proteomic approach by mass spectrometry. We analyze the titin and all the muscular proteins by an approach of mass spectrometry, and we do separation and analyze the different peptides of the titin. So it enables us to demonstrate. So we can see a part of, so you can see in red the present peptides, and we can see the peptides, and we want to see if with distillation, we still have some protein, or if we don't have any protein at all, because it's degraded. And we also want to see the other proteins. If we can find some protein markers of titinopathy, and if we can analyze more precisely and more exhaustively the deregulated proteins in titinopathy, we will be able to find some responses and physiopathologic assumptions. And what I've shown today is that the genomic analysis have enabled some correlations between some mutations and some clinical pictures, and they have enabled to evidence some new clinical pictures. And in the myopathy with early onset, there were some studies that evidence some mutations of the mutations of this protein, and examples for the forms of congenital arthrogryposis and deficits in the dreyfus muscular dystrophy, and maybe this phenotype due to a secondary deficit in MYHC2. But there still have some secrets of this titin, the variability, the clinical variability in a family, in one family, the recessive forms without second variants, and the hypothesis, the assumption is that there can be digenism in this myopathy, and maybe there is the intervention of the epigenetics, and that's where the animals or cell models should help us to progress. And there were several studies, and you can see some zebrafish models or other types of fish. So I thank my laboratory, and especially Aurélien Perrin, who is at the basis of this project. He's an engineer financed by the AFM and the University Hospital of Nîmes. Javier Morales, who has done the thesis for us, but who's now gone to Barcelona. Charles Van Goem, who was doing an internship in master. Eloise Fort-Groton, and so we can include other centers and the consortium. We have the center coordinated by Willem, and we have done a titin consortium with all the researchers. And if you are interested to participate, it's open to all. Thank you.
Merci beaucoup Mireille, c'était passionnant. C'est la première fois que je t'entends sur ce sujet.
Mais il y a Internet ici.
I'm very pleased and I'm very happy not to...
Bon, mais merci beaucoup. Est-ce qu'il y a des questions dans la salle? Moi, j'en aurais une, vu que c'est une...
It's a structural protein of the muscle that interacts with many other proteins. Did anyone look at the transplantation of this protein? Some studies on a cellular model of these channels. I don't know, I'm not sure how far they went into this research. Transduction channels. We have a project with a research team as well. It's not only a mechanical connection, but possibly it's also has a role to play in the signaling. They set out, a team has showed that there is a deficiency in inflammatory ways. It's not only, it comes only in the second place, it is complex. Down the same line, do you have different species? The T-tine, do you have different species? Can you look at, study it from in basic silicons, for instance? Silicons, I don't have any studies in mind. Studied in mice, yes. In Drosophiles, 2 genes in Drosophiles, and the evolution was grouped in 1 gene, and in my fish, we took them out of the trials because 55% of similarities between fish protein and others. So there are other possible modeling that look more interesting. There are some projects, ongoing projects, but to me, it's still, not complete, final.
C'est dans jeudi. J'avais pris.
Is quadriceps muscle?
I cannot answer. In the study that he had made, that Savarez had made, it seems that he didn't evidence some differences, but there should be. But so far that I know, I cannot answer. We try to take the same muscles because we think that there might be some differences at the level of the isoforms or after for the expression, the relative expression of each isoform. So this is another level of complexity. Thank you very much, Mireille, for this very clear explanation in the vast world of titinopathies. After that, we have the pleasure to welcome the incredible Guillaume Saul, who's from Bordeaux, whom you appreciated as a moderator, and is talking about muscular diseases with facial involvement. If you take only 25 minutes, it will be better than 30, well, without making pressure on you. So I will go fast.
So I'm going to tell you about I'm going to tell you about muscular diseases with facial involvement, practical approach in medical consultation from Bordeaux. Well, I'll tell you about why the muscles on facial muscles and contractions are pathology. So my agenda is muscular diseases with facial involvement, front, second, and first. Okay. Well, this with ptosis. And ptosis that can be, I'm not going to teach you about myasthenia. I'm just going to use one single case and see how we can reflect on it, on this issue. It's 24, young man, former diagnosis, nocive facial expressions. A neurologist has sent him to us for ptosis and fatigue. Diagnosis is myasthenia diagnosis, and is really. He said he wants to commit suicide, and self-esteem. He can't do any sit-ups and push-ups, and instead he's going to kill himself. And so my colleague did the electromyogram that didn't set out any specific issues, and that was first intervention, and antibody, anti-ROSC, and all came back negative. So there was a first care with symptomatic corticotherapy. There was a small clinical residue, and he still was still because. And she asked me, is it myasthenia? And so, is it a ptosis? What is a ptosis? Ptosis, you can measure it, and your eye is wide open. The lower lid is going to come against the iris, and as you can see, you can see the lower part, but the lower part of the eyelid and the iris, and we're going to measure the distance between those 2 points. In a normal case, a normal eyelid, you have the upper eyelid that goes down to 2 millimeters. When the higher upper eyelid covers the iris, then there are several systems of of classification of the ptosis. So the question was, with this patient, is it ptosis? And we measured 4 millimeter. We measured. Is my ptosis muscular, as a muscular origin or tendon origin? So we look at the eyelid, the eyelid. Take the eyelid and the eyelid, and so that the muscle that lifts the upper eyelid so that the muscle that lifts up the eyelid, the tendon must be the fully functional position. And in this case, the only thing that would link up the muscle, this is with slices. It's a small muscle. We call it the muscle of Muller muscle. And when there is a lesion, a tendon lesion, and the muscle is going to weaken, and therefore there's no myasthenia, but just the fact that tendon, is altered. What the ophthalmologists do is they measure distance between this lid here, this eyelid, and the bottom of the upper eyelid. When there is more than 8 millimeter, well, it's typical of an alteration to the tendon. Something which should wonder, and the patient can tell there is a slight deviation or change. 25% of ptosis, acquired ptosis, could be post-traumatic, could be following surgery as well, and with aged seniors, and those also wearing lentils. And so I don't know what serial. Okay, so my patient, it's 8 millimeter. It was 8 millimeter. When you measure between, so ptosis is myogene. There is hypothesis that it's a myogene ptosis. The eyebrow is at the same. You can see that the eyebrows are raised. You can have some kind of action of facial muscles. If you can also, if you want to find it, you can find another way of doing this. You can lower the upper the eyebrow, and the eyelid is going to lower. So that's a sign that we can use as well. We're going to use use another system to identify ptosis. We're going to ask him to look to rest his eyes and then look up straight ahead of him. You can see the eyelid. And you can see that his eyelid is not. It's a sign, but it is not typical. I mean, it doesn't mean that it's a good argument anyway. I don't know if you've seen it. We're gonna ask him to look upright, and you can see that there is a weakness in the muscular. So there is a facial myasthenia. So this is Kogan sign. Another patient here. Is it myasthenia, seronegative myasthenia? She asked her to look down and see some contraction of the muscle around the eyelid. And when we ask her to look ahead, it's the contraction of this small. This is not a ptosis. So both eyelids are contracting. It's an argument against the that that's not that is not this is not apoptosis, not compensation. So it's a functional pathology, not apoptosis. So I therefore my patient had a myasthenia, and she checked, so 10%, 7%. There was no indication that there was a decrement, 10% of loss. And because she didn't test the right muscles, the distal muscles of the upper limbs are very specific, and it's not the most affected muscles. And therefore there is a strategy which is different. Here you have the small muscle Ancone, which allows you to test and explain to the patient when what you're going to be doing with the patient, and the patient is more relaxed, and therefore goes along with what you're going to be your examination. It's another muscle you can test, and the stimulation of another of this muscle under 10,000 amperes, and on the second trial and test, not trial test, 10% loss, and it's a real life. It's a real. I mean, it's a real. It's a real. I mean, that's actually the actual results, and it's not nice. Okay, on the other side now, testing the other side, and myasthenia, and then nasal, and the real decrease 20% decrease. Eyelid loss. So there's 35 minus 34%, minus 35%. So therefore, indicators are highly developed or high indicators that it is a myasthenia. A lot of articles written on the various strategies to do. Minimum strategy is ambicular of the eyelids, trapezius and Ancone, and then you're going to adapt your test and to support to gain more supporting evidence. So start with the symptoms, bilateral way of this your testing, cover many various parts of the face. There is an article that shows that post effort testing is not really positive. While the Gwendol, still the MG. Facial myasthenia. She's constipated. She's 70 years old. She's got backaches. She's not feeling well. Sometimes fainting a bit, and the dryness of the mouth. Ptosis, clinical ptosis and areflexia. So we ask her to look down and then look up, and you can see it's not obvious here, but there is a little sign of slowness. Myasthenia, but what about the walking, dryness of the mouth, and yes, I know it's not in order. She's got a ptosis, she's got a compensation of the forehead. Under 10 millimeters, she could have a disinsertion, but no disinsertion, and she's got this electromyogram. So motion or a movement. We ask her to do some under effort and doing some movements and post movement. And she's a lumbar. She's got the Lambert and Eaton syndrome. usually that doesn't indicate that you have myopathy. Single fiber electromyography, not that easy and straightforward to do. Therapeutic testing, young patient. She's filming. She's doing. She's a myasthenia with a stosis, just one way, and she was tested. The therapeutic test is an excellent testing technique to confirm ptosis, and she's publishing on TikTok, and she's volatile. So this young man, I'm going back to my initial patient, couldn't do push-ups, and he wasn't seronegative. Some patients are negative, that are seronegative, while we actually test them, and afterwards they can turn into seropositive blood samples. And there are anti-mask, bulbar, facial, axial, and EMGs, which are the proximal and facial muscles, and it's important to have diagnosis, as you can go straight into the anti-sigma. Antibodies as well, RP4, so I'm going to go quickly, not as severe cases of this pathology. So, as I mentioned before, let's bear in mind that we can also leave out some other diseases, so we must really be aware that there are other syndromes, myasthenic congenital syndromes. It can be diffused in myasthenia. Can have pseudo-myopathic signs with multiple responses. Treatment are very specific. Some patients, some mestinone, for instance, quite a few patients are reactive to this and allergic to it. And one of my patients actually had to go into the emergency room for quite a few days because of this. So post-traumatic aggravation. Another pathology in 2008. 25 years old man, ATCD, paresy 3. 2008 was sent for ptosis left, fluctuating ptosis. He's under corticoids, and nothing comes of it. He's seronegative. He's a nurse, and he doesn't like seeing. Well, he doesn't like being. He doesn't like doctors really, and we didn't really get his myasthenia, so he does a brain and MRI, and we find lesions, whereas he myasthenic back in the first time in 2008. And therefore, it's not the myasthenia that caused his trouble at the time we saw him the second time anyway. So another case, 50 years old, no ATCD, other personal family. So he was sent to me by a colleague. He said, I don't know, just check, so retrieves, no response, and these patients we tend not to see. He's got ptosis. Now, the diagnosis we need to do properly. Under 10 millimeters, so no disinsertion between the higher part of the eyelid and the lower part. So this patient is seen again. I see him again, and I reconsult. So another consultation, and we talked about it this morning. Looks left, right. So there is a paralysis, eye paralysis. It looks down. no Kogan syndrome. He's looking up. He's got the ophthalmoplegia, external one. And we ask him, when does this ptosis started? Well, he's 43 when he does his ptosis, his driving license. In the photo on his driving license was already showing the ptosis. So that ptosis went back to way before he thought. So delusion, mitochondrial delusion. So we'll know that. So I'm not throwing any stones at anyone, but a lot of patients, with ophthalmoplegia that we're treated as myasthenia. It could be some slight discrepancies between these patients, and ophthalmoplegia progressive one before 50 you turn 50, and after 50 it's another kind of another type of symptom. Ophthalmoplegia, there is an affection of the facial muscles, and often we can't see it really. They are older patients, and that's just a sign. The wrinkles on his forehead that just shows that his effort to lift up his eyelids. There are family in Canada. And the onset of the diagnosis is just diagnosis is 25 military in the military without ATCD. Doesn't look like myasthenia, myogenic, and it comes to see me, sent to me by colleagues. And they tell me, my colleagues, you need to do a biopsy, muscular biopsy. So he's got a whole kit of muscles and just over 3 millimeters, under 10 millimeters, so no desensation. And how to check for ptosis. So he's got, he's coming at it as a pump disease. So muscular affections or with orbiculars. So typical patient, he finds it difficult to. I know you can't see, right? Can you see the other videos? Yes. Did you see? Well, okay. Sorry. FAHD with takes on over. So sorry. Diffuse facial affections. He's in your waiting room. He's got the facial expression, no expressions. His sister is with him, who looks, the Steimer disease. He has Steimer disease, and the father who also has a Steimer, so myotony and cardiac. Paramyotonia. Going back, we ask the patient to look straight ahead. We'll ask her to look up. So myothonia of the upper eyelid, and she can't close her eyelids. I'll show you again. She's looking up. Congenital myasthenia, and she can't, once she lifts up her eyelids, and then she can't lower them. We'll see the same on the orbicular. We ask her to close her eyes, hard, and then she tries and open her eyes, but it's hard. So it's rare. It's a rare disease, and you can see that in congenital and we're trying and asking her to look sideways, and same thing will happen. And that can really show, what is a myasthenia, and same with identify myasthenia. So facial affections, facial involvement with facial involvement, muscular disease with facial involvement, facial affection or involvement. A lot of things, with these patients as well. It's early onset or early onset. Can have oculum in the myocyte inclusion, sporadic inclusions, myositis. Can have a facial involvement. Can be diffuse. Usually, what we tells us that it's affected, and the person is really this muscles, the arm, the lower arm. Also, when the patient is trying to close his hand, he cannot close his hand. Briefly, you can have different facial involvement, rhythm, diffuse with left on the right. One last thing, just have in mind that 70-year-old dysphagia sent to me for dysphagia, maximal. We ask her to pull her tongue out, and she can't. She's a dysphonia. She's a muscular biopsy that did not provide much information. MRI scan, brain MRI, and hypersegnolingual. No ATCD. She's 70, and she sent to me for dysphagia, and she's a pump disease. She has pump disease. So ptosis in the firstly, myasthenic syndromes, under 50 years old, myopathy, mitochondrial. Over 50 years old, dystrophia, muscular dystrophia. Other diseases as well, you must bear in mind, pump, orbitopathies, orbicular in the first rate, diffuse affection or involvement, myotony, Steinert, myotonia, congenital myasthenia, early. Could have ptosis as in this room, which probably are due to the time. Hopefully I didn't send you to sleep. No. Thank you so much. One of your position, I am lucky to work with him as a semiologist, and he tells me, and I learn from him, new science, to identify new signals, on a daily basis. Do we have any questions? If no questions, you know what? Yes. There is one question. We have one question. Well done for this presentation. Excellent. Yes. When you do a stimulation test, repetitive, negative, can you do easily? Can you send the Fibronic? Yes, we have two Fibronic. Yes, we do. We have two staff that can do this. The point really often is to do this to rule out any other issues. Yeah, we find unique fiber, not fibrosis, unique fiber testing. We'll do this if there is a doubt. Otherwise, we'll try not to do this unique fiber testing. Thank you. Thank you very much. So last but not least, we're going to have Philippe Després. He's a resuscitator, a pediatrician, and I'm really lucky to work with him and for respiratory care for small patients. We are lucky to work with you.
Thank you, Elizabeth. So we have the chance to work with you in the marathon that we have in Guadeloupe. And I think that we can say this because today I spent 5 years on the phone to to solve the problems of bronchiolite and neonatology. And so I'm happy to have this half an hour with you. So you have you had some ebonist presentation, but it will be more raw materials this afternoon. I want. So I would have told you to go to taste the Alpha 300 yourself in the next room. And thanks to the explanations of Oliver, I understood what I've been prescribing since years. So we will talk very briefly about generalities because we had very nice presentation made by specialists. So the Duchenne disease is a neuromuscular disease, but a lot of material are common to the management of all these diseases: Duchenne, the serious myopathies, Friedreich diseases, spinal amyotrophy, type 1, 2, and 3s, and the Pompe disease and myasthenias. We could have talked about other subjects concerning the respiratory management of the Duchenne, the Boulogne, the vaccines, the administrative and social management, and the ethical aspects. But today I will talk about pediatry because I wouldn't be able to talk about the adult medicine, and we will talk about the respiratory management in the physical aspect. We will avoid to talk about the action of corticoids, etc. So physiopathology can be summarized in a simple diagram. If you want to take one idea about this from this presentation, it will be this representation with a blue circle, with a triangle, a red triangle, and a black square. So in the Boulogne, in Duchenne de Boulogne, we have a situation of normality with a central command, a central order command is the blue circle. A muscle action, which is normal, is the red triangle, and the charge of the load of the muscle, the charge of the muscle is normal, is the black square. And then we have a decline of the muscular strength, progressive loss of the strength of the diaphragm, which will be preserved at first. The students think that myopathy is a patient who has weak muscles, but in the child, this is essentially retractions, and so what we will see now is to increase the size of the red triangle, but before that, reducing the size of the black rectangle. And first, we will set up some systems, physical systems, in order to fight against the defect of compliance of the rib cage and the lung. So decreasing the load on the muscles, opposed to the muscles. And then we will talk about non-invasive ventilation, because as a reanimator without reanimation in Guadeloupe, this is something that we handled quite easily, so easier than all the preceding steps. So in parallel of this physiopathology presented in a simple way, but which is realist, there is an insufficient cough when the expiratory volume is lower than 200, about 200 liters per minute, and this insufficient cough exposes to more infections, and the installation of a chronic respiratory failure, which can be restrictive. And in the Duchenne, the volume and the consistence of secretions are normal. So some therapies that we will set up quickly for the mucoviscidosis won't be used here. And so the weakness of the diaphragms makes the patient dependent of the perithoracic muscles. And the scoliosis in itself, which is coming in the end, in this thoracic or thoracolumbar scoliosis, reduces in itself the compliance of the chest wall and the lungs of 25 to 50%, and then the dysphagia, progressive dysphagia, which can go up to the severe inhalation of food, of some food, and this can be a cause of death of this myopathy. And so we will fight against three compliance defects: the lower compliance of the lung parenchyma, and so this is the moment to talk about alpha 200 or 300. The lower compliance of the rib cage, and the lack of compliance of the family and the patient to the treatment. That's what we in Guadeloupe we can experience this lack of compliance of the families. It was the case in Alsace in France, but it's more in Guadeloupe, with a population which with reduced communication means, and with people saying that after 1 year and a half they were waiting for us to call them in order for them to make an appointment. So the physical means at disposal for the management of the Duchenne disease, there are the evaluation tools. We shouldn't forget them, ignore them. So the one the one that we don't have in hospital, it's the continuous oximetry, and fortunately the service providers are here. Thank you, Isis, Ceprodome, SOS Oxygen, Vitalaire. Maybe I forgot some of them, but they give us the key for a refined surveillance. And sometimes they pose the Semtech captors at the hospital when there is no oximeter capnogram, transcutaneous capnograph, and EFRs, so the lung function testing, according to the capacities of the laboratory, so 5 or 6 years to ask a child with myopathy to do an EFR. And when the muscular strength is at more than 50% of the normal, but as soon as this difference is reached, there is a quick degradation of the performances. Difference of current volume between sitting position and lying position of more than 25%. The polysomnography, so the peak flow at cough, the polysomnography. This is a machine that is easily obtained by medical general practitioners, but that we don't have for children at the hospital. And because of the age of the child, and because there are possible obstructive apneas, and also central apneas, and of course night hypoventilation. The frequency of assessment, simple spirometry once a year in the walking patient after 5-6 years, spirometry and night oximetry and capnography twice a year in the non-walking patient, and polysomnography with capnography. The respiratory physiotherapy, and I went to them, and I met the former physiotherapist that I had in Strasbourg, and yesterday I met him. That's a real pleasure, and thank you for your last time explanations. The physiotherapist, a major actor in the management of children with myopathy, and with the physiotherapist comes with his tools, with an alpha 300, a cough assist, VNI, so non-invasive ventilation, and I want to insist on the manual work. Do we have an interest in wiping a tired horse? That's what we say when we does it worse to work in performance with a muscle which is quite tired? I think this was discussed, and one of these and the devices is the cough assist, the machines for children with myopathy, and it leads to an hyperinsufflation, which is not very high, so 15 centimeter of water. It's not huge. Later, when you have 40 centimeter of water, you feel you pre-explosive, and and then suddenly you induce a depression in the respiratory airways with a nasobuccal mask with a cushion so that it can be hermetic, and you impress the depression, and suddenly you improve the clearance of the secretions that are non-sticking, non-viscous in the myopath patient, contrary to the mucoviscidose. And once the patient has seen the interest and the comfort of the cough assist, he insists to have a session. So it can be increased, the frequency can be increased in case of intercurrent pressure. And some patients come with the cough assist when they are decompensated, and it enables to show our staff how it operates, and it helps to avoid the viscous plugs. But this is a material which is equipment which is offered by the service providers, which provided by the providers, and also there is a percussive ventilation, non-invasive. It can be very efficient in some pathologies. So there's no, but we don't have this material in our university hospital in pediatry unit. It can be, yes, comfort cuff. It can be used, and it combines the cough assist and the percussion effect in the same machine, and you have to change the nozzle. The pressure relaxer, alpha 200 or 300. So 300, alpha 300, it's really the basis material that we suggest to the patients. But the pressure relaxer is something that we could prescribe very largely. We've begun to do this when we were discussing one with my colleagues and with Elizabeth, and we realized that first the providers had to buy this material in order to be able to provide this. And a few years ago, there were zero pressure relaxer, and now we have about 10 to 15 in Guadeloupe, but a lot of them are blocked at the customs. But well, then we have to learn to use it. It can be a game in front of the TV, twice 10 minutes per day, and the setting is purely clinical. So 2 eyes, 2 ears, 2 hands, a small brain for the practitioner, but that's sufficient. And more dramatically, the moment of while you are under a non-invasive ventilation, in the spirometry, the degradation can be sudden, and but the parents describe more agitated sleep, a respiration which seems more active in the day, but with a capnography, the patient was at 42 on average, and he culminates at 60, and so we established this non-invasive ventilation at 2 levels of pressures. The CPAP only is not good because we have a difference between the basis level and the respiratory level. In order to manage the hypercapnia, you have to have a catching up frequency, and there are tendency to central apnea if the patient don't reach 15 level. So we have to have a respiratory trigger, an expiration trigger to have a long inspiration, and so you have to have this with the patient in front of you, and the report of the user of this machine, which is provided by the service providers. In pediatry, we begin to say that oxygenal therapy can lead to an hypercapnia also in children. So the modalities, well, I won't enter into details, but this is the mask is a nasal, is a nose mask with calibrated leaks, and it will be linked to a monobranch respirator. You cannot use a respirator with 2 tubes with a calibrated leak, with a leak mask, and so because the air has to be expired on a side, so either there is a calibrated leak, and if it's hermetic, you have to have a comeback to the machine. The spirometry will be better, but the system is heavier, and so we prefer the nasal and monobranch systems. You have one of them in demonstration in the next room. I've seen a Vivo 50, and it's smaller than a computer, and before that it was 20 kilos, so this is progress. So objectives of the non-invasive ventilation, so the improvement with the PEP, volume recruitment technique, and I would like to insist on something that we don't think of. The patient with hypercapnia, a chronic hypercapnia, will tolerate his hypercapnia. The fact to set up a night ventilation And the patient during the day will have a tendency to compensate a beginning of hypercapnia while reventilating as much as he can. And if I can have my ventilation during my rest, it's better. And hence the ethics of the interest of tracheotomy, surveillance, the clinics, regression, diminution of the signs of retraction. The respiratory frequency won't be the same in the VNI, in the non-invasive ventilation. FiO2 and SARS-O2 improved. Arterial gasometry, no, we are not fan of these invasive techniques. Surveillance monitoring of tolerance after deficiency. For the skin, we have a tendency to tie the nasal-buccal interface to in the children to put it to very tight for the child. But the problem is that a child in the night who vomits in the night can die, and because he cannot express himself and take it up. And so there is a risk of gastric distension with a nasal buccal mask. Also, we have to be cautious about leaks, risk for the eye, for the ophthalmologic tolerance, and the cough assists. For the cough assists, when the peak flow is under 160, or a saturation of oxygen regularly less than 95%. And when we say it's not possible to put this pressure on the patient, a cough effort is more than 100 centimeter of water, but it can be up to 300 centimeter of pressure with the cough without no thorax. So it's not aggressive, it's just impressive. The alpha 300, in practice, it's set up as soon as the family is ready, and it becomes a game. We have to set up a network between the prescriptor and the physiotherapist and the child himself, so that there are three actors around this machine. So when should we begin a non-invasive ventilation? So the scientific answer, we are supposed to calibrate this transcutaneous capnography if we have some capillary with this. We don't have any capillary for capillary gas blood. We don't have these. We have only venous gas, blood gases in Guadeloupe. And so the overall response is when should we begin the VNI? So when there is an indication on medical criteria, when the patient and his family adhere to the project. And people don't know that in the respirators there are some devices which can be there are some sneaks that can capt some captors and some probes, and there was a mother and it was detected that the child hadn't put on his mask every night. And actually, the mother told the child, "But I told you that you had to use it every night," and she said he didn't obey, and so if the child forgets his ventilation, we should encourage him to take it and encourage the mother to replace the children's hands to put on this mask. And we have to encourage the service provider ensuring the maintenance of this material. And now I want to tell people, be careful in this machine. There is a device which can be interrogated remotely, read or interrogated. So the place of tracheotomy in the respiratory solutions. So it's in the AFM Congress. It's to discuss case by case. And if we don't follow the patient's advice, it won't work. A patient who doesn't want a tracheotomy will do everything to avoid it, and it could die from this tracheotomy. And even in the case of a lot of symptoms, the patient can say no. And in this case, we have a law, the basis of our pediatric reanimation. We shouldn't go to fall in unreasonable obstination. So as a conclusion, we have to reduce the gap between the reality and an optimal management. It's our aim. Elizabeth, who comes to help us regularly, and we have two strong assets in this, the service provider and the physiotherapist. Thank you. Thank you very much.
Thank you very much, Philippe, for this presentation. And feeding back on your daily life, and I'm not bored, that's for sure, work-wise. Any questions from the audience? No question, just to tell you that from the hospital center in Cayenne, French Guyana. Yes, they can't hear you. If yeah, working at the hospital center in Cayenne, French Guyana. I'm health staff with the pediatrician unit. And your story, well, we know exactly what you were coming from, but we got capillary gasometry. We got 3 gas measurement. Okay, we're going to come to you, and there's a resuscitation unit, obstetrical. Obstetric, and one in the laboratory is actually at 4, and another one in another department. So we got 4 of these machines. I'd like to ask you a question. The pump disease with a child with pneumopathy. So every 3 to 4 weeks we have this child. There's an intake. She's got VMI at home. And each time she comes back, we have the OptiFlow, the just regular VMI, and repercussional. But she died. She passed away. Yeah, I know you have I know you have a lot of pump disease patients. Yeah, you know. sad stories. High flow. It's not VMI. There's no there is no PEP. Yeah, it's 400 centimeters, but of water. But it's not. It's providing some support, and it's a ventilation support in terms of recruiting or intake. Yes, but it's not helping with the breathing. So gastrostomia. Yes, well. I believe, yeah, it's a severe form and lately cured. Otherwise, you don't get to this stage, as they're at an early stage. She was 3 with cardiomyopathy, which possibly was not making things any easier. So when you talk about, when we have in mind VMI with artificial feeding, with a nasobuccal mask, and we're just feeding, you need to feed in the stomach, but you have to empty it. So yes, with her mother, she was really close. She knew everything, she was really, caring for her child. The last time, so when she did the last inhalation, it was outside the unit, and yes, and therefore, well, she could, she probably fed her the wrong way. Okay, thank you that it's not just us. Thank you for feeding, sharing this with us. Just one comment. Recommendations have been updated in 2021, and adult pediatrics, all indications, and you need to check. I don't know if it is still ambiguous or not. It's on the AHS website and on the sector or the Yes, well, anesthetist in Gorge and Olivier Fléchel from resuscitation unit in pediatrics unit in Fort-de-France. Just one comment. We need to highlight the social background and social environment of the children when you are, living in forest in the middle of nowhere, and tracheotomia. If you live in a city center, it's just slightly easier, and these should be part of our discussions and included in our discussions, and living conditions. Sometimes should provide some insight as to what to do, how to do anything. Thank you very much for this presentation that puts things in perspective. Caring for patients, they are symptomatic carers, medical carers. On these thoughts, food for thoughts, we give you an hour and a half, and then it's going to be drinks. So an hour and a half, it's 6:45. We will be back here, well, not here, but downstairs at 8 p.m. Don't go just right downstairs, and there is a dinner that's been booked at the Batelier Beach Club. So we just got to walk all the way down to by the beach.